Hi there, students. This is Dr. John, your physics and math professor, coming to you with another trig function introductory video. Today we're going to explore the standard definitions, sine, cosine, and tangent, and then expand a little bit upon that. So just for review, let's just take a look at just ignore this part here for now. And let's just take a look at the very basic definitions of sine, cosine, and tangent. This is how you write them out, the sine of the angle theta, cosine, tangent. We usually don't use that full word there. We'll use the shortcut sin, theta. Some people pronounce the sine, some people pronounce it sin. Both are okay. Sin is sort of and this they might say cos instead of cosine. That would just sort of be shorthand, and here would be tan or tangent theta. So this is the shortened form, the abbreviation for these slightly longer forms here. And here's what they mean. So here we have the sine of this angle. Here I've drawn a right angle triangle. All of these refer to or reference back to right angle triangles. Here we have a right angle triangle. This little square in there shows that this is 90 degrees. This angle right here is 90 degrees. The other two add up to 90 degrees because all the angles inside of a triangle add up to 180. And so we have the opposite for this angle here. We have the opposite side labeled with the letter O, the adjacent side labeled with the letter A, and the hypotenuse labeled with the letter H. Now, of course, you might say, well, this is also adjacent to this angle. Yes, it is, but because it's the longest side, we call it the hypotenuse, and we just leave that the label, and the other one would be the adjacent one. So if we're going to look at this, we say, what is the sine? The sine is the opposite over the hypotenuse. So I'm going to write that out here as being the definition O over H. And the cosine is the adjacent over the hypotenuse. We covered this in another video. And the last one, the tangent here, would be the opposite over the adjacent. Opposite over the adjacent. Another way that you could define the tangent is it's also equal to the sine over the cosine. So that'd be like an alternate definition for this. This is also equal to, let me just make this an equal to, this is all equal. This is also equal to the sine of theta over the cosine of theta. It's another way of looking at the tangent function here. So all of these things are equal. Sine theta is equal to that, which is equal to the opposite over the hypotenuse. And this one over here is all equal to that. So those we covered in another video to introduce the basic or the standard three trig functions, sine, cosine, and tangent. But then we said, okay, look, these things define this angle. The opposite over the hypotenuse specifically define this angle, and as does the adjacent over the hypotenuse. Any of those ratios do. So then we asked ourselves, well, why can't we go the opposite? Why can't we go H over O? Why do we have to go over H? Why can't we flip that over? Well, that's what we have these reciprocals for. The reciprocals are, in fact, this flipped over. So what this long one here, cosecant, this actually has an abbreviation as well. I'm going to write that in here, right? And the abbreviation is CSC of theta. You couldn't use COS, cos, because that is this abbreviation. So they're using the first three vowels, the first three consonants, C, S, and C, cosecant angle theta. And this here means specifically that it is exactly this thing, but it's flipped over. So that's equal to H over O, or you could define it another way. That would be the same as saying 1 over the sine of theta. All of these three things here are definitions, so it's just simply the sine flipped on its head. This would also be equal to sine theta, and then you put brackets around it, all to the minus 1. It's very important you put brackets around the whole thing. That puts that in the denominator like that. So now we'll look at the secant here. The secant is actually the same thing here. It's the flipped of the cosine. So the abbreviation for that is the first three letters, since that doesn't apply to any other function. SEC of theta, which is equal to this flipped over, so H over A, or that's also equal to 1 over the cosine of theta. That's cosine theta all to the minus 1. So now we have these three. This one here you can sort of figure out as well. I'm going to do it the same colors here so you can see the match. That would be, the abbreviation for that would be just cot. Some people might say cot, or cotangent, which would be this flipped, so it's A over O, or equaling to 1 over tangent theta. If we want to write it like this, we can do it just the same way, and we can go tan theta all to the minus 1. So here we have the three common trig functions, and then the reciprocals, which are not used as often. You probably need to sort of know what they are. It's a little bit complicated and it's a little bit tricky, and here's one of the reasons why. Notice this is sine, or sine like this, and this one is cosine with a CO in front. But here, the one that associates with the sine has the co in front, and the secant is the one with just the straight old definition. So this is cosecant, and this is the secant. This one is sine, and this one is cosine. So you would expect that the one with the cosine, the one over the cosine, would be the one with the co in front of it, but it's not. And I'll explain that to you in another video where we see the origin of the word secant. But for now, just have to take this. This is a chart right here. There's a lot of information on this chart. There's also a download on my website where you can download this whole thing, and you have it to print out right there. It's all free for you, so just go and get it, physicsdoctor.com. Now I'm going to look at, so these are the reciprocals, and now I'm going to look at one more thing that we're going to need to know about trig functions, and that is the inverses. So let's say you have this sine of theta is equal to 1/2, and you want to know what the angle theta is. So what you do is you have a function that you apply to the front of that. You apply this to the front, and that function is called arc-sine. And you apply that actually to both sides. You can usually apply a function to both sides of any equation, any equality, and it's still going to be an equality. So we used to have sine theta equals 1/2. We apply this function arc-sine to both sides. What this arc-sine does, it undoes the sine function in a similar way to the square root undoes a square function. And all you're left with, and these two actually cancel each other, and you're left with the angle theta is equal to the arc-sine of 1/2. And the arc-sine of 1/2, you would punch that into your calculator and find out what that is. So on your calculator, you're probably going to have a sine button, and then small writing on top of the button in a different color, maybe in a lighter color, that says arc-sine. Or it might say sine to the -1x, which means the function that undoes the sine function. You're going to have to push the second button, or the function button, to get the top thing here, and then you can use this arc-sine function to undo the sine function and find out what if you have 1/2, what angle would that create. So you use the arc-sine on that, and you're going to have this on your calculator like that. I'm just going to tell you a little bit more about this, just like before. For the sine thing here, the arc-sine, it's called arc-sine. It has to do with a circle, and we won't go into that right now. But the arc-sine, another way that we might write that is it might be written inverse sine. It might be written in or inverse sine. And this one over here might be written inverse cos. Or they might write the whole word out, inverse cos. It's an inverse function. It undoes the function. I'll explain that again in just a second. And this one would be the inverse of tan. So on your calculator, you might have something called the arc-sine function or the inverse sine function, or you might have this function. It'll be called sine to the -1x, something like that. And this one over here would be cos -1x. And this one would be tan -1x. Now notice there's a difference here. Over here, if you're doing the cosecant, which is the reciprocal, the sine in the denominator, you have sine theta to the -1. That's just the way that you would normally write it. So for example, x to the -1 means 1 over x. You just put this in the denominator. X to the -2 means 1 over x squared. That's how you would do that. So this here, sine theta all to the -1 would mean 1 over sine theta. However, this in here is a little bit different. It has a different meaning. And I'm very sorry that that's how they defined it. It's very confusing because it's very easy to confuse with this. But just think of this. This here is the negative power on the outside of this whole thing. So you put the whole thing, see, you put the whole thing in the denominator. But this is the -1, or the inverse, on the inside of the function. It's between the sine and the x. And this means you would take this and say, I'm undoing the sine function with that -1. However, just to confuse you a little bit more, sine -1x is the arc-sine of x, or the inverse sine of x. However, sine -2 of x is 1 over sine x all squared. So this power up there, if that power is -1 and it's between the sine and the x, or between the tangent and the x, it means arc-sine. However, if this power is anything but -1, let's say it's 2 or it's 3 or it's -2 or -3, it means it is a regular power over the whole thing. A negative power, of course, puts it in the denominator, a positive power. So this here, sine squared x, means the same thing as this, sine x all squared. However, the only case it does not mean the same thing is when it's sine to the -1 x. I think they did that so that you could write scientific papers and you could put things on your calculator that were much shorter. And they tried to figure out a way to write out the inverse of sine in a way that was a little bit easier, so that it's really confusing for a lot of people. Just remember this, in this one case, and probably in this only case, this means inverse. So if it's a -2 or -3, or if it's a 2 or 3, it's a regular power. But if it's a -1, it's defined as the inverse over here. I'll just show you what the inverse is once more. So let's say you have the sine of some angle is equal to √3/2. And if you wanted to calculate this, you would have to say, what I want to do is I want to undo the sine function in a similar way to this. The square root of x is equal to 4. If you say, well, I want to know what x is here, like I want to know what's inside that thing, I have to undo the function, which is I have to square both sides. So the inverse, or the undoing function of the root of x is this whole thing squared. So I have to do that to both sides, and I'm going to get x is equal to 16. I've now solved this here for x. I have undone this. And you can do the same thing over here. So if we want to solve this, we have to say, I want to undo this sine function because I want access to this angle here. So I want some function that's going to undo this. The function that does that is this one. So I have to apply that to both sides. Sine -1, or you could write arc-sine of what? Of this whole thing here. This whole thing here of sine theta is equal to what? I have to do the same thing over here. Sine -1 of all of this, √3/2. So what I do in my calculator, I realize the sine, the arc-sine of the sine means, just like the square root undoes the square, just leaves me with theta. It pulls out this theta here is equal to this. Now what I'll need to do is put √3/2 into my calculator, probably punch in √3 divided by 2, and then hit the arc-sine button. Remember I told you before, you're probably going to have a sine button, and then inverse sine, or arc-sine, or sine -1x, any of these things written on top of there. Use that function, and you're going to undo this, and you're going to get the angle, and I believe this angle is 60 degrees, if I'm not mistaken. And in the next video, I'm going to help you to understand why we name sine, cosine, and tangent, why we even give them those names. In another video, we're going to look at why we give them these names as well. Hopefully these videos help you understand these things that can be a little bit tricky for people who are seeing them for the first time. If it did, like and subscribe. I'll see you in the next video. Bye-bye.